Okay, welcome back. In this video, we're gonna try to prove the following. So we're gonna let A be any element in R. We're gonna prove that the derivative of the cosine at A is minus sine A. So here, this is a classic problem that you will see one time in your life, or you're gonna do it one time unless you are teaching, okay? And this is a one life experience. Okay, here's how to prove this result here. So we can do this one. There is an easy way and there is a beautiful and elegant way to do it using trigs. Okay, here we see that, or we know that if we let f of x is the cosine, because that's the function that we want to differentiate. So here we want to prove that f prime at a is minus sine a. That's what it means here. Okay, and we know from we're gonna use the definition here. So this means that this is f prime at a is the limit as x goes to a of f of x minus f of a over x minus a. Make sure that you know the trigs formulas, because when dealing with these trig functions, we will have to use a lot of trig identities. Okay, here if we plug f of x, let's write it down in fact. So the limit as x going to a, so f of x is just the cosine, and f of a is cosine a over x minus a. Okay, here we can use trig identities to find the limit, or we can change the variable. Okay, so we can change the variable and use other identities as well. So here, instead of taking x going to a, we can do this change of variable. So when x goes to a, if we change x minus a as y, so when x goes to a, y is gonna go to 0. So this is the same as y going to 0 of, so here x is gonna be cosine of x. X is gonna be here, it's gonna be a plus y minus cosine of a. So x minus a is just gonna be y. Okay, and we can use the what we know from trigonometry as cosine of a plus b, with a is a and b is y, and expand the formula here. Okay, so you can do this. So the limit as y goes to 0 of, here the cosine is just cosine a, cosine y, okay, minus sine a, sine y, minus cosine a over y. Okay, so here we can factor out by this cosine a here. We'll make it easier. So the limit as y goes to 0 of, so it's going to be cosine a, cosine y minus 1 over y, minus sine a, sine y over y. Okay, now we see that we have other formulas that we need to prove. But before doing so, we're going to expand this limit, because we are assuming these limits are finite. So here, so we're going to get the cosine a, the limit of cosine y minus 1 over y as y goes to 0, minus, here sine is a constant, so we're going to have the limit of sine y over y. Okay, so we have to prove many results here. So this one here and this one here, this is the very famous limit here. We are not going to prove this one. Sine of y over y as y goes to 0 is 1. So we know this limit. So what about this one? Cosine y minus 1 over y as y goes to 0. Okay, so here we're gonna use a change here that we can do. Okay, so to find this limit, it's a 0, in fact, cosine y minus 1 over y. So we can do the following. So we know that the cosine of y is, if we write it in terms of the sine, it's going to be 1 minus 2 sine squared of y over 2. Okay? And therefore, cosine y minus 1 is just minus 2 sine squared of y. Okay? And if we take this one here, let's do that. Let's write it down. So it's going to be minus 2 sine squared of y over 2. And once we divide by y, we're going to have this one here. Okay? If we multiply here, if we divide by these two here, and we multiply the top and the bottom by 2y, we're going to have, in fact, let's multiply by 4y. So here we're going to have y over 2 squared. And here we're going to have 4y's. And we know this limit here. So here, this limit as y goes to 0 is what? It's 1. And this one as y goes to 0 is 0. Therefore, we have only this one here, minus sine of a. So we have minus sine of a. And that's what we needed to do. So that's what we started here. See? So f prime of a is minus sine of a. That means the derivative of the cosine is minus sine of a. Okay? So there are other ways. So here, just note the change here. So how we get this limit here? By writing cosine y as 1 minus 2 sine squared of y over 2, and taking this one here and dividing by y, we had to make this one look like this one but squared, because this one squared is the same as this one. Think of this one squared as sine of y over y times the sine of y over y, which is 1 times 1. And this one is 0. Okay? So this is the change that we had to do. Okay? And I think that's it. We did explain this limit. We know this limit. We had to explain this limit. So this is 0. This limit is 0 times the cosine of a is going to be 0, and therefore we have 0 minus sine of a times 1. Therefore we have minus sine of a, and that's what we needed to prove here. Okay, so that's what we needed to prove. Other ways we can do to find this limit here. Okay, so we said this is a classic way of doing this one. So it's using the trig formula for the difference of the cosines. We can use that and we find the same thing. Okay, so the cosine of x minus cosine of a, it's going to be in terms of the sines, and from there we can get the result that we need. But this is enough. Okay, so you do it one time in your life, or maybe this is your last time that you're going to see it. Okay, try it yourself if you want to. If you see any errors or mistakes, please let me know. And thank you again.